Hello everyone. First of all, we thank Emertex Information Technology for providing this opportunity. I Vijay Kumar Patel with our team member Harshit Singh. We are excited to present our project Simulation of Washing Machine using PICSIMLab. We are currently pursuing bachelor degree in electronics engineering from REC Sonbad. Without wasting your time, comes on slide. So, in this project, we have learned about the brief introduction, embedded system and its component, software used, PIC microcontroller that we have used, PIC16F877A microcontroller, embedded C, peripheral description, project demonstration, and in last, sample output. We show the output of this project. First, introduction. Our project is based on washing machine. Washing machines are used to reduce human labor and save time. Washing machines have an important place in the modern society. Nowadays, we can see various kind of washing machine. Customer want to have fully automatic washing machine instead of semi-automatic. In this project, we have built a simple washing machine prototype using PIC16F877A microcontroller. Now, second, embedded system. Embedded system is a combination of both hardware and software electronic gadget to do a specific task. We take an example. Example of embedded system include microcontroller in household appliance like washing machine, industrial control system in manufacturing plant, navigation system in automobile and medical device like pacemaker and insulin pump. These all examples contain both hardware as well as software. Now, type of embedded system. Based on performance, it is classified into two parts. First is based on performance and functional requirement. It can be classified into four parts. First is real-time embedded system. Second is network embedded system. Third is mobile embedded system. And last, that is fourth, standalone embedded system. And second, based on performance of microcontroller, it can classified into three parts. First is hard real-time embedded system. Second, firm real-time embedded system. Third, soft real-time embedded system. We explain one by one. Real-time embedded system. A real-time embedded system is an embedded system which are designed to take an action or decision within a specific amount of time. It is a time-bounded system. If time is not bounded, then there is a loss of human life or some other things. Second, network embedded system. In network embedded system, multiple devices or components are combined to perform a specific task. Example of network embedded system: home automation system, Wi-Fi router and Bluetooth system. Third, mobile embedded system. It is an embedded system which are movable from one place to another place. The common example is mobile phone. The fourth is standalone embedded system. A embedded system which take decision with its own without human involvement. It is an intelligent part in its is said to be standalone embedded system. Example are modern washing machine and based on performance of microcontroller. First, hard real-time embedded system. In hard real-time embedded system, the delay are not strictly followed. Example are airbag and pacemaker. Second, firm real-time embedded system. In this embedded system, there is not a life loss but property loss take place. If the embedded system are not working as it is expected, example is fire alarm. Third is soft real-time embedded system. In soft real-time embedded system, it expects some amount of delay. Example, washing machine, microwave, oven. In this, there is no life loss. Now, coming on component of embedded system. We say that embedded system is a combination of hardware and software. It gives a input, process and give the output. Sensor take an input. There are various type of sensor like light sensor, gas sensor, smoke sensor, moisture sensor and various type of sensor. It goes to A to D converter, that is analog to digital converter. Then CPU, it is a microprocessor that process the data. And further D to A converter, convert digital to analog converter. And final actuator. Actuator gives the output through LED, buzzer, LCD and memory. There are two types of memory. First is RAM, second is ROM. RAM is random access memory. It is volatile memory. This means that data stored in RAM is lost when computer power is turned off. And ROM, read-only memory. It is non-volatile memory. In this, data is not lost when computer power is turned off. And one is FPGA, that is Field Programmable Gate Array. Now pick microcontroller to build this project. we are used PIC16F877A microcontroller. It is most commonly used microcontroller by industry. Common specification: it has 40 pin. It has 4 ports in total. Port A 6 pin, port B 8 pin, port C 8 pin, port D 8 pin, and port E, that is 3 pin. And other pin are used for power supply and ground. It supports serial communication for its 2 pin TX RX, that is transmitter and receiver. It can support SPI protocol, Serial Peripheral Interface Protocol. It has oscillation frequency range from 4 MHz to 40 MHz. Clock frequency range of 4 MHz to 40 MHz. Now coming on software which are used in this project. PICSIMLab. PICSIMLab is a virtual simulating software which is used to simulate our program. MPLab X IDE, XC9 compiler, PICGenius PIC16F877A MC board, which are shown on our screen. Now coming on embedded C. C language is simple language than other programming language like Java due to its efficiency, portability, and low level access, enabling prescribed control over hardware and optimal resource utilization. Data type and variable. Understanding different data type and variable declaration for efficient memory use. Pointer and memory management. Manipulating memory address and accessing hardware register directory. Control structure. Implementing decision-making logic and repetitive tasks. Function and modular programming. Facilitating modular software design and reusable code block. Preprocessor directivity. Manipulating source code before compilation for defining constant and conditional compilation. Now coming on peripherals. LED. A light emitting diode is a semiconductor device that emits light when an electric current passes through it. LED is commonly used in various applications. LED is an external device connected to microcontroller. A port is interface between the controller and external peripheral. LED are commonly used in various applications including indicator, display, illumination, and as component in electronic system due to their efficiency. LED has two port. First is anode, which has longer in size. Second is cathode, which has shorter in size. Now coming on tactile switch as digital keypad. Switch. Switch are used to on or off the power. Switch are often used as input to control the operation of the device. When the button is pressed, the switch turns on, and when the button is released, the switch turns off. They are typically connected to a specific input pin on the microcontroller, enabling the detection of the switch state change. Now coming on CLCD. It is a part of actuator which show the output in physical form. CLCD character liquid crystal display. Liquid crystal display is a flat panel display technology that are used liquid crystal to modulate light and display image or text. LCD operates by modulating light through liquid crystal controlled by electrical signal. Important pin for interfacing with LCD including power, VDD and VSS, control RS, RW and E, the data line D0 to D7 along with the constant control pin VO and backlight pin A and K. Now coming on interrupt. Interrupt in microcontroller are two types: hardware interrupt and software interrupt. Interrupt are signal that temporarily suspended the normal program execution to handle critical event or external stimuli. The interrupt come at that pin which have higher priority. They stop the normal program and execute the higher priority interrupt program. After that, they run the normal program execution. Now last, timer. Timer in microcontroller are hardware module used for measuring time interval, generating prescribed time signal and implementing time critical operation. They can be configured to operate in various modes including timer, counter, pulse width modulation and capture or compare mode, catering to a wide range of timing requirement. It control over the timing resolution and period essential for applications such as motor control, communication protocol and real-time system. In washing machine, if the time is over, the fan or motor get stopped and our buzzer is ringing. Now next part of this project is explained by our other member.
Now we are going to start the project demonstration. So as a starting part of the project demonstration, firstly we open mapxid where we have programmed the whole program of washing machine. So as you can see all the sources files here and also the header files here. Now we will be using the clean and build the main project option to build and generate hex file. So as you can see the build is successful here and now the build generated a hex file in the particular destination. As you have seen, XCV compiler has compiled the whole program and generated a hex file which have seen the destination in the xid. Now we will be loading that hex file. So we have reached the destination and we can see the hex file here. So I have loaded the hex file as it showing we should press key 5 to turn on the washing machine. So washing machine has turned on now. We can see various washing machine programs like daily, heavy, dedicates. And now to see more options we can scroll down, and to scroll down we are using the RB3 switch. We are going to sort, press, and it will be scrolling down. So it has scrolled. We can see whites are the new options: dry only, wash only, aqua store. Again we come back to daily. Now to select any of the functions we have to long press RB3 mode. So I have long pressed RB3 by putting my pointer on heavy option. So I have selected the heavy options like that. Now we have come into a water level screen we where we can auto low, medium as water levels. By using the same to scroll, we will scrolling down. We can see the high and max as another options in water level. So I am selecting high using the long press option, so I can see that the water level got selected and I have been forwarded to the next screen where I can see that if I press switch 5, that is RV4, I can start the program. And after starting, if I want to pause the washing, then I can press switch 6, that is RV5. So I have started it. So just to check, I have pressed the RV5 button, that is switch 6 has passed the washing clothes off. Again again to resume it is I am pressing RV5 and RV4, that is switch 5. Resume now. So we can see here RV4 is the switch, that is 5. Now we can see here the functions got changed from wash to rinse. So you can see that when the program has completed washing machine, so it has buzzed with a buzzer which give an alert that washing machine has been completed, and we can remove the cloths, and we have completed the program and it has started back to starting slide. So with my demonstration gets completed. Now we have conclusion for the project. This project successfully demonstrate the design and simulation of a washing machine using a PIC16F877A microcontroller. Key embedded system principles we applied to: first is control real-time process using timers and interrupts. Second is interface hardware peripherals like keyboard, CLCD, buzzer, and fan. Provide a user friendly, that is third option, provide a user friendly interface with mode selection, water level configurations, and process feedback. Now I want to thank you.